Okay, today we're going to look at section 2.2, which is called graphs of functions, and we're just going to look at graphs of functions in a variety of ways. So for the first one, we're going to start with this basic example of negative x squared. So negative x squared, based on the parent functions, which, if you don't remember, you looked at those in Algebra 1 and 2, x squared was a parent function and it had that general shape. Well, I'm actually going to make this ink a little bigger. So if you have a negative x squared, then it would be that same image flipped upside down. So I graphed it on the Inspire calculator and I have this image here. That is our function. So if you're creating a table for this, this one's easy because we already know what x squared looks like. So this would, if I just have values in my table from -2 to 2, this will sometimes work if you know what the function looks like. If you don't, which we'll look at an example, the table values you choose may not give you a clear image, but that's okay for now. So if I plug in these numbers into negative x squared, I would get -4, -1, 0, -1, and -4, which gives us that symmetry around x equals 0. I'm going to change this one thing. Should say f of x. Okay, so that's our first one. We would sketch the image. It's shown in the calculator picture, and that one's almost too easy to start. So if we go on to something a little bit different, so 4x squared minus x to the fourth is not a function that we usually call a parent function or anything like that. So if we just choose these values, let's do the same thing that we did for the last one. We plug in numbers into this. We would have, first one would be 0. And -1, if I plug it in, it would be 4 minus 1. So this would be 3. At 0, I'd have a 0. If I plug in 1, I'd also have 3. And then if I plug in 2, I'm going to get the same thing as -2 because x squared, both of these are even powers. So we plug that in and we'll also get a 0. So on my graph, if I just plot those points, I'm going to have a point at 0, 0. And I put some dots there. I'll have one at -1, +3. So 1 point there. Have one at 1, 3. And -2, 0. And at 2, 0. Okay, so if you don't know what that function looks like, it might be hard to connect those lines. I know that the function looks a certain way, so I can connect these like this. And we'll kind of get to a place later on in the class where we talk about why I would know that looks like that. But if we go over to a calculator, we're going to look at some functions here. Okay, so if let me turn that one off. Here's the function that we just graphed. So this is 4x squared minus x to the fourth. So that's what we'd call a fourth degree polynomial because the largest exponent is a 4. So if we just look, I had entered some of these earlier. So x squared, if I put that on the graph, it looks like that. Okay, that's what we'd call a parent function that we're used to. If we, on that same graph, put an x to the fourth, it's got a similar shape. It's doing pretty much the same thing as far as the ends of it. X to the sixth is going to be this purple line. X to the eighth is the red. And as you can kind of see that they're all following the similar pattern. So the blue line is our x squared, and then the larger the power gets, the general shape stays the same, but the graph shows this flattening in the center of it. So if I zoom out pretty far, these all look similar, but they're not, not the same, but they have the same general shape. So this is what we call a family of functions. So any even-powered x to an even power is going to share a similar shape like that. Now, if we look at the odd power, so here's x to the first, that's just your straight line, right? Your linear function. If we put an x to the third there, these two don't appear to look exactly the same right now, but they follow the same pattern as the even powers. So if I put an x to the fifth there, so purple line, x to the seventh, the black line. So what it's doing is taking that center and it's still showing that flattening behavior. So x to an odd power is also considered a family of functions. So if you look at an x to the fifth power, that graph is going to share the same characteristics as x to the third. So let's go to our next one. So we did domain and range in the last section, and we're going to look at that again, but we'll just take this from a graph, which is actually easier. So the domain is simply the the x values that the graph takes on. So this would be the domain visually. And this number, or not this number, this part would represent the range. So from a graph, these are generally pretty easy if the function doesn't have any holes or numbers skipped. So for this one, the domain, you're really just looking at the lowest number and the highest number. Since this is a continuous line that's drawn, it's easy. So the domain goes from -3 all the way out to +3. And the range is going to be the lowest y value taken on up to the highest y value. So this is, at the axis, that's y equals 0. And then it goes all the way up to this y value, which is 3. So from that graph, the domain and range is pretty simple. Let's look at another one that might not be so clear. So for our next example, the shape isn't as consistent. So what I'm going to do first with this is just mark out where the graph begins and ends in the x direction and as well as the y direction. So I'm going to go down here to this scale, and this looks like it's at -8. The graph goes all the way out to this value, which looks like it's at 11. This point is the lowest point on the y-axis, and that goes down to -4. And then the highest point is at 8. Okay, so I've done most of the work for domain and range. So if I look at the x-axis, I have this -8 and 11. So that's my lowest value to my highest value. And since this is an open circle, that is going to get a parentheses. So open circle means not included. And for the 11, we have this closed dot or filled, means a bracket. Okay, so 11 is included in that domain. For the range, although there's no, we're really looking at this value here that I circled, there's no point defined there, but there doesn't have to be as long as it's not open. So if there's no open circle there, therefore it's included. So we'd go -4, and that goes up to 8. And we have that same situation at this 8 at the top. There's no open circle, therefore it's included. Okay, let's go on to the next little topic here. So this section is just a variety of little things we're going to take care of. So are all relations functions? Now, a lot of you did the vertical line test in Algebra 1. You may have done some of it in Algebra 2. And a very simple definition of a function is a function will give exactly one y value for every x value. And what that means is easily seen when we work through a couple of examples. So what you do with these is just solve for y. So if I add this x squared to both sides, I will end up with y equals 3 plus x squared. And the question is that a function? That is a function. And that's because it just tells us why is this stuff on the other side. And so it's easier to see what isn't a function when we look at those examples. Okay, this other example, x squared plus y squared equals 9. This is a circle. So you can graph a circle, but it is actually, well, we'll look at it here. If we try to solve for y, I'm going to subtract x from both sides. So I get y squared equals 9 minus x squared. And if I take the square root of both sides to get y alone, I will have y equals plus or minus the square root of 9 minus x squared. So the question is that a function? And what we're going to look at is the plus or minus. So what that's telling me is that y is either equal to the positive square root or it's equal to the negative square root. So it is not giving you one value. So if I plugged in a number in for this x right here, I would get a positive value that comes out and I would get a negative value. So it's not giving me one value, it's going to give me two. So this is not a function. So a circle, if you were to enter that on a calculator, generally you have to enter that as two separate equations, which is the positive square root and the negative square root. So the positive would be the top half of the circle, the negative would be the bottom half of the circle. So algebraically, that's how you would show whether something's a function or not. Solve for y, if you get plus or minus, not a function. Okay, so this is the vertical line test that a lot of you have seen before. Let's look at the first one that says a function. So we're looking at this one. So that is a function because no matter where I go, if I, for instance, where I put this line, if I go up to that, it gives me 1. Again, it's going to give me one value for y. If I choose here, it's going to give me one value for y. So there's no other place at this tick mark that there is another value. So it's just one, it's one output for every input. So that would be a function. If we look at this one, this is not a function for the same reason. Now it fails more than just in that spot here. But so here's a value, and here's a value. So if I were to plug in whatever number this is at, that would give me 3 values out. Similarly, if I chose, here, it's going to give me 3 values out. So as soon as it's not one value out, it's not a function. So the vertical line test is just a test where we visualize a vertical line being dragged across the function. And if your function crosses that vertical line more than once, it's not a function. Okay, so let's just look at applying this, and I have a visual here that might help. So is this a function is our question. Well, let's take a vertical line and we just drag this across our function, and if it has more than one place it goes through, it's not a function. So it's a function, 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 until we get to here. So it's just like the last one. So this fails in this region, and then we can drag it out here, and that's fine. But it doesn't matter if it's fine everywhere else. This would not be a function based on that. This fails the vertical line test. Okay, if we take that same black line, let's take it here. So we're going to test it on this one. So we take it, drag it, green line and black line intersect once everywhere along this. So that would be a function. Okay, last example we're going to look at is just how to find values from a graph, and this is pretty simple. So for this problem, the x-axis represents our hours, and the y-axis represents power. So typically if you're found, so this would be p of h, that's the name of the function. So I'm going to move that up here. This is p of h. So if you were asked to find p of 6, all you will do is go to hour 6, which is right here, and go up to where your line is, and that looks like it's at about 500. Okay, if we just do that a couple of times, let's go p of 12. We go up to our graph, and that looks like it's probably at 850. So some of the problems will ask you to pull values from a graph, so that's all that's doing.